This is the third video in our series of rational roots theorems. The first two videos dealt with x cubed problems. These problems are going to be x to the fourth. The process is going to be similar with a little twist. Now, to review from the previous videos, the directions, find all the zeros of the polynomial, is the same thing as saying solve the equation. It doesn't matter the way it's phrased, you've got to do the same thing, which is find the possible rational zeros or the possible rational roots, whatever way you want to put it. Because the coefficient here is 1, all I have to look at is the last number and write down the factors of that number, which are 1, 2, 3, and 6, plus or minus of all of those. So that's 8 possibilities that could work in our equation. And all we have to do is just start and try. So we'll start with 1, bring down the 1 and do the synthetic. 1 times 1 is 1, gives me 3. 1 times 3, add and get negative 6. 1 times negative 6 is negative 6, gives me negative 22. And you can see this is not going to give you 0, so 1 does not work. So let's put negative 1 in here. Negative 1 times 1 is negative 1, add and get 1. Negative 1 times 1 is negative 1, gives me negative 10. Negative 1 times negative 10 is positive 10, which gives me negative 6. Negative 1 times negative 6 is positive 6, which gives me 0. So that's great. We have found one zero, or one root. Here's the problem. If I fill in these variables, because this started out as x to the fourth, this is x cubed. We can't solve x cubed. We're going to have to find another root by doing synthetic division. So let's erase this x cubed. These are the coefficients for the equation that has x cubed in it. We want to use these coefficients. Do not go back and use the original coefficients. I like to think about this as being a big old equation with lots of numbers. And what I want to do is whittle this down to have less numbers, which would represent an x squared equation. So we've got to work with these coefficients doing more synthetic division. And the good news is whatever number or numbers you have already tried that do not work, they will not work again. But negative 1 could work again. If you have a polynomial with multiplicity 2 or 3 or more, then this negative 1 could work again. So before you try another number, you should try negative 1 again. So we'll do the synthetic on this. Negative 1 times 1 is negative 1, gives me 0. Negative 1 times 0 is 0. Add and get negative 10. Negative 1 times negative 10 is 10. This will not give me 0. That says negative 1 does not work again. There is no extra multiplicity on that root of negative 1. So I'm done with the ones. Positive 1 didn't work in the beginning, so I don't have to worry about it. We check to see if negative 1 worked again. It does not. We're done with the ones. Time to try the 2. Put a 2 here. Bring down your 1. 2 times 1 is 2. Add and get 3. 2 times 3 is 6. Add and get negative 4. 2 times negative 4 is negative 8. Nope, that's not going to work. I'm going to do a little thing here. Just change this to negative 2 and change a couple things as I go here. 2 times negative 1 is negative 2, which would make this negative 1. Negative 2 times negative 1 is positive 2. Negative 10 plus 2 is negative 8. Negative 2 times negative 8 is positive 16. That says 2 didn't work, negative 2 did not work. I can cross those out. So 2 didn't work, negative 2 did not work. Time to try 3. Bring down your 1. 3 times 1 is 3. Add and get 4. 3 times 4 is 12. Add and get 2. 3 times 2 is 6. Add and get 0. Bingo, there is our other 0. And the other good news is because I've just got 3 coefficients here, this is standing for x squared plus 4x plus 2 equals 0. All we have to do is continue like we did on the other videos, and that is solve this either by factoring or using the quadratic formula. Before we do this, let me just review something again. This was x to the fourth. When we found that first root, it's now an x cubed. Well, we still have to find another root. When you find the other root, then it bounces down to x squared. We are in good shape because we know how to solve anything with x squared in it. This does not factor, so we're going to have to use a quadratic formula, and this is all the work for the quadratic. Here's the equation. Here's your quadratic formula. Here's your values for a, b, and c. This right here is just stuffing in the a, b, and c into the quadratic formula and then doing the arithmetic. Negative 4. 4 squared is 16. 4 times 1 times 2 is 8, which gives me 8 under the radical. Do your factor tree on that, which gives you 2 radical 2. Look at your triangle trick here. I can factor a 2 out of everything. 2 goes into 2 once, 2 here twice, 2 here once, which simplifies into negative 2 plus or minus the square root of 2. That's 2 different roots. Combined together with what we found on the other screen of negative 1 and 3, that's my 4 roots. Recall that the power on your equation dictates how many roots you're going to have. So x to the 4th is what told me I was going to get 4 answers, and that's what I got. Similar problem, we're going to name the possible rational zeros. Because this coefficient is 1, all I got to do is look at the last number and name those factors, which are just 1 and 2. Of course, plus or minus of those 1 and 2. 1 times 1 is 1, and I get 2. 1 times 2 is 2. Get negative 1, add and get negative 2. 1 times negative 2 is negative 2, which is 0. You need to try 1 again. 1 times 1 is 1, add and get 3. 1 times 3 is 3, add and get 2. 1 times 2 is 2, add and get 0. 1 works again. That means 1 has multiplicity 2. Let's fill in our variables and solve this equation, which factors as x plus 1 times x plus 2 equal to 0. Set these equal to 0 and solve. This will give you negative 1. This one will give you negative 2. Combined together with the 1 that we found already, even though it had multiplicity 2, you don't need to list it twice. So these are all of our zeros, or all of our roots of this polynomial equation. All right, this time we have a coefficient in front of x to the 4th. So when we name our possible rational zeros, we've got to look at factors of the back, which would be 1 and 2, and factors in the front, which is 1 and 2. Fortunately, there's not many factors, so when we do our fraction thing, there's not going to be a whole lot of factors. So put 1 over 1 is 1. 1 over 2 is a half. 2 over 1 is 2. 2 over 2 is 1, which we already have. So here's our list of possible rational zeros. What we want to do is start trying our synthetic division. Just to save time, I'm going to tell you that 1 and negative 1 do not work. You can stop the video, do the synthetic on that, and take a look at it on your own, but it doesn't work. So that brings me to 1/2. You might be afraid to try the fraction, but if the fraction's going to work, the arithmetic is kind of nice. Bring down the 2. Half times 2 is just a plain old 1. That's great. Negative 3 plus 1 is negative 2. Half times negative 2 is negative 1. Negative 9 plus negative 1 is negative 10. Half times negative 10 is negative 5. 9 minus 5 is 4. Half times 4 is 2. Gives me 0. That says 1/2 is one of my roots. If you get a fraction or a decimal in the middle of this, that says this fraction is not a root. If it's going to be a root, things are going to work out evenly because it's got to cancel out at the end. So the next thing that works, just to save time, I know that negative 2 works. Using negative 2 on these coefficients, bring the 2 down. Negative 2 times 2 is negative 4, gives me negative 6. Negative 2 times negative 6 is 12, add and get 2. 2 times negative 2 is negative 4, add and get 0. Fill in your exponents and your variables. This is 2x squared minus 6x plus 2 equals 0, which I would like to try to factor this. I see I can factor a 2 out of this, which is x squared minus 3x plus 1 equals 0. I don't need to retain that common factor. I could just think about dividing both sides by 2, makes those cancel out. 0 divided by 2 is still 0. So this is what I'm trying to solve right there. It doesn't factor, so I'm going to have to go to the quadratic formula. Here's my equation. Here's the quadratic formula. Here are the values for a, b, and c. This is the work for stuffing in the a, b, and c, which when you do all this arithmetic, you get 3 plus or minus the square root of 9 minus 4 over 2, which is just 3 plus or minus the square root of 5 over 2. Along with the 1/2 and the negative 2 we found on the other screen gives me my 4 roots or zeros or solutions, whatever you want to call them.